Also, I don't think we're really just talking about skills. I think we're talking about a culture.
Hmm.
Scientific culture is about questioning the data and being skeptical. And I just don't think this is something you can learn from a textbook or even necessarily from a YouTube tutorial. It's it's something that it needs to be imparted to you by someone who represents that culture.
Hmm.
I think there is a really strong cultural aspect to this that I think people miss sometimes.
Yeah, I mean, it's not something that critical read. There's been some debates about whether or not, for example, critical thinking can be taught, and I don't believe that critical thinking can be taught like in a course type thing, where essentially you lecture people on how to critical think. Because even the fact is, if you take those and apply it, you're not critical thinking; you're just mimicking. Um,
Mm,
and I think that there has to be, I don't know, there's some aspect where it has to be like that dialectic with an experienced skeptical scientific thinker. And then you also have to be basically out on your own doing it. You have to be able to survive in the wilderness of science. And it's learning those survival skills and picking yourself up again when you make mistakes that teaches those skill set. Hey everyone, today's guest is Dr. Martin Goodson, CEO of Evolution AI and author of a recent paper responding to the UK's AI roadmap document, in which he brought up some really interesting contrasts and difference in priorities between AI strategies for government versus startups versus academic research institutions. And I thought it'd be great to bring him on to essentially discuss what sort of those competing priorities are. So, Martin, welcome.
hi.
Hey, and I guess just to start, like, just to lay the groundwork, what was this document to which you're referring to, the AI roadmap?
Yeah, so the AI roadmap was published by the UK government it was put together in January of 2021. It was put together by an organization called the AI Council, which is a group of people who the AI government had asked to help them and support them in their progress towards the publication of the UK AI national strategy. So the main document was the strategy. The roadmap was the planning for the strategy. The strategy itself actually came out in September of 2021.
So the roadmap was essentially a precursor. Was it meant essentially when it was written? Was it meant as a statement of what the strategy would be, or was it more like feelers to try to get some feedback before finalizing a strategy?
So it was a major input to the strategy. Definitely, I don't think the idea was that every single idea in the roadmap would go through into the strategy, but it was one of the main inputs. I would go as far as to say it was the primary input into the strategy.
Cool. And just so we get an idea, what were sort of the key aspects of the roadmap itself? So the original document. Um,
Yeah, so they covered a lot of ground, and that's one of the criticisms that we made actually. And I should say that the article that I worked on, I didn't work on that by myself, but that was part of our work as the Royal Statistical Society Data Science and AI section. So a bunch of people worked on that, and it was mainly based actually on a survey that we wrote that we made. But one of the criticisms that we made of the roadmap is it's just covered too much stuff. It really covered. It was like it was such a long list of different topics that it didn't really have a coherent core idea at all. So it went from the skills gap in AI to moonshots. So it spoke about things like the digital twin idea, which I'm not even really sure what that is in terms of AI. And um, the, the the idea was what one of the main ideas that they proposed was that the government should sponsor major moonshots. So this is one of the things that we criticised it for because what's the real evidence that the governments are very good at running AI moonshots or that this is the best use of public funds? And it really did cover a lot of ground.
yeah, that is interesting. When I was reading it, it seemed like very broad. Like I generally don't like critiquing too many things when the authors aren't around to respond or anything. But in general, I thought that's like when I was trying to read this, it's I was expecting one thing when we started talking about a roadmap, and it seemed like very non-concrete, and it was very broad. I also only heard about digital twins for the first time in March of 2021, so that was also another thing. So I guess it is surprising a lot of people that effectively it seems something like a subfield. Maybe it's not worth going into, but it seemed like it was a subfield that was getting sort of like hoisted up there as an integral part of a strategy.
Yeah, I don't know if you know about this. There's a researcher in UCLA called Richard Rummelt who researches on strategy, and he has this idea that many strategy documents just come about from committees who have a lot of stakeholders, essentially just everyone contributing some ideas that they would like to have accomplished. So you end up with this long list of goals, which are not really a coherent plan. And he says, you don't. This is not a list of tasks. It's just a shopping list. It's not really a strategy. This document had some of the flavor of that. It's something that was made by a committee.
Yeah, when I think about these things, I think about more like the analogy, by way of analogy, it's like mosaicism and entropy, where effectively, like, how much surprise is there in a document given what you just read? And if you go straight from like Moonshot to digital twins to skills gap and things like that, it's like that's a high entropy document. And effectively, if it doesn't fit together. But I guess maybe just to move this on to the Royal Statistical Society. The data science and AI section. Is that the name of? Yeah.
That's right. Yeah.
So essentially, it's the Royal Statistical Society's equivalent to the statistical learning and data science section of the American Statistical Association. At least I like to think so. And basically, you surveyed your members. You got a pretty large feedback from them, and then of them to review the document. And this review document is essentially the basis of the article that you wrote.
Yeah, exactly. We actually had a great response. We read the roadmap and we thought we need to make a comment on this. It doesn't seem like the technical community, like the kind of practitioner community, as we call them, the actual data scientists and AI specialists out there building products and services. We didn't think they've been consulted at all. So we thought, well, there's a gap there, and I think we need to fill it. But does anyone really care? We had quite a lot of debates in our committee meetings. Does the practitioner community really care about this? And we thought, well, let's just survey them and figure it out. So we sent the survey out, and we had almost 300 responses, and really detailed responses. A lot of them from quite senior people, a lot of leaders, data science leaders in industry. And the response was really amazing, actually. We were really, really surprised, and we were really happy with the response. It was especially the detail. People have some really great ideas out there, and which we just didn't even think about. So yeah, we were really glad to see that.
Yeah, just as a quick side note, as someone who has run surveys for professional societies and sections of professional societies, getting response rates in the hundreds and the multi-hundreds is phenomenal. So
Right.
that is a massive success, and especially if they came in detail. And from reading your response, there was a cohesive detail. Is that when read some of the quotes, like, this is written by people who are actually in the trenches doing machine learning AI work. You mentioned the term practitioner. Can you tell us what that means to you?
So when we talk about practitioners, I mean, it's a kind of a loose term, but we are talking about people who are doing data science or AI, machine learning. They may be doing research, but they're not necessarily working in a university, probably working in industry. So people who are actually building, we're really concentrating on people who are building things. So people who are building products, building services. Many of them will be working in startups, but we're not really talking about those people who are working in universities as researchers, because we think those people are really well represented already. Most government policy work seems to concentrate on universities, maybe just because they have really good links, or maybe because in other industries, universities are who you should speak to. You should really speak to, professors in universities if you want to talk about cutting edge, early stage drug development or life science research, maybe. I don't know, but in AI, I don't think it's right. I think that the practitioners, the people in industry, people in the startups are really driving. I mean, the whole data science thing, which started 10 years ago, I think was really driven by industry. It wasn't driven by universities.
Yeah, I would definitely agree with that. Especially sort of the definition of data science has become essentially, to me, it feels like something where industry needed to come up with a name for the skill set that they needed. And the reason that data science becomes a little bit of a nebulous term is because essentially there's a great diversity in the skill sets that they need. But it's essentially saying like, we need someone who's not quite a statistician, who's not quite an engineer, but effectively has this right combination of skills. If you don't mind me asking, just to circle back, you mentioned that practitioners mean people not effectively in academic research institutions, because there are plenty of academics who are building things. And I like your example of the life sciences. We need cutting edge information, for example, from someone like Andrew Pollard at Oxford University. There isn't like an Andrew Pollard and then there's a practitioner of what he does. It's effectively his research is the cutting edge thing, and presumably he works with industry and it gets it delivered to create, for example, the ChAdOx vaccine. Whereas in data science, machine learning, AI, we have the people building models, particularly like heavily in academia, and then there's, as you said, the people building things, who that's essentially their entire focus. What would sort of differentiate a very applied researcher in academia from somebody who's, say, building something in a startup?
Um, yeah, nothing. You're right. Yeah, I think there are many people who have that. I mean, they're not really. They're doing something. They're applying algorithms. They may be doing research in order to build, uh, you know, better algorithms for their products, but they're not necessarily publishing on those algorithms. They're doing something quite different to what most people think of as a university machine learning researcher, which is, their goal is to publish papers.
Yeah. Yeah. I think that is actually one very important thing, just, the time that goes into publication, for example, where effectively if a practitioner is not putting the time to that, that is, as far as how they allocate their time and what they have time to do, I think that's an important issue. Hey, folks, we're a few minutes into the show. This is usually the part where the podcaster talks about their sponsor or something. I'm not going to do that, but I will ask two things. One, if you could leave a like or a dislike based on your preference, and also let me know what you think about this topic, and also what topics you like discussed on future episodes of the show. That's it. Enjoy the episode. You're CEO of an AI startup. What are the priorities of essentially a startup or these practitioners? What are they trying to do? We'll go with that.
Okay, so most of the time in this context, I think what we're trying to do is build really accurate models that have the performance characteristics that are appropriate to the use case. So in many cases, in my case, for example, we're really interested in computer vision models which can work very fast. They need to be very accurate, but they also need to work very, very fast. So most of our work is extracting data from documents, images of documents, like PDFs or scanned images of documents. And we're extracting from about 1.5 million pages a day. So we really need high performance methods. So maybe that's quite a niche requirement, but in most cases, machine learning engineers and researchers in industry are trying to build models that are very high performance, have good accuracy, work under the computational constraints that you've got. You might need to have something that works in 100 milliseconds or whatever it is. But also there's a whole other side of the characteristics that are needed, which are, I don't know, maybe I just call them under the umbrella term of trust related characteristics. So for many use cases, not so much in our particular use case, but in many use cases, you really need to prove that your algorithms, have the fairness characteristics that you're interested in as well.
Yeah, and on top of that, do you need to add the fact that people will have to buy these algorithms? Or does anyone effectively buy an algorithm, or do they pay for a service that is essentially powered by an AI algorithm? There's obviously a commercial bit to this as well.
Yeah,
Yeah.
absolutely. Yeah. Hopefully, the reason why you're building these algorithms is that you have products of some kind that you want to that you want to solve some kind of business problem.
Yeah. And if you don't wouldn't mind, could we sort of dig into that a bit? Because I think that is a massive difference between, for example, like technical publications, academic research, where effectively you're looking at the performance of these things, and performance metrics can be the end all. Or if you're really fancy, you can do interpretability without losing performance. But for the practitioner, it doesn't end with just saying, "Oh, I have this thing that performs well." It needs to essentially fit into a greater ecosystem, like a software ecosystem, and that software is what's being sold. Is
Sorry,
that
Ben,
accurate?
I don't think I understand the question.
Oh, is that an accurate representation where effectively there's this facet for practitioners where they need to effectively fit in with a greater technical ecosystem like the software that is powered by their AI with the customer feedback and things like that. And
Okay, yeah. I think that's a good way of representing things. They're not The algorithm is not existing in isolation. It has lots of different touch points with other software systems and also human-based systems, business systems.
and if you don't mind me asking, since you're a startup CEO, does it differ? So, for example, like compare the work that you have to focus on versus someone like Jim Weatherall, who's part of a like large, well-established company. Do the practitioner priorities change between those two things, or is there that much of a difference?
Yeah, that's a good question. I mean, obviously, we're a much smaller organization than AstraZeneca.
Yeah.
However, most of our customers are quite large organizations. So we do work with banks and other large organizations, which are probably, comparable in size to a company like AstraZeneca. So in the end, we do, I do find myself having conversations with lawyers, internal lawyers, and ethics advisors, AI ethics advisors, and other people within the larger organizations in order to make sure that we are working under the constraints that they've set for governance. So I think in that respect, sometimes I do, but part of my job probably is a little bit similar to someone's job working in a larger organization, but much of it is very different because the products that we're building really in isolation. I mean, we're building it. It obviously needs to work, and the customers need to be happy. But most customers don't really get a say in what kind of algorithms we're using, what our R&D methodologies are, or anything like that. We get to choose that ourselves. So I hope. I mean, the idea is that a startup can move a bit faster than a large organization because of that.
Cool. And so far, because I'm just trying to get a really good idea about what it means to be a machine learning practitioner, because that's obviously the thing that this AI roadmap in your commentary is differentiating itself from. Have I forgotten to ask anything so far? Like, is there any key point that I've missed out on?
You mean on key points on what a machine learning practitioner consists of? What a machine learning
Yeah. Just
person?
any
Yeah.
like sort of key ideas around that I've missed out on so far.
Not really. The only thing is that we're definitely not just representing machine learning people. I mean, we are representing data scientists who might have a different slant on what they're interested in. Then there are definitely data scientists who are more on the statistical side, or maybe are not as involved in machine learning research or machine learning products, for example. However, they're still practitioners. We still include them in the umbrella term of a practitioner.
All right, cool. So now back to the AI roadmap. What were the things that, for example, an AI practitioner would have liked to see in the AI roadmap? Yeah, let's start with that, and then I'd also like to ask, as sort of like a startup CEO, because those are two different hats, what they should have seen in the roadmap. But let's just start with the AI practitioner. What would the AI practitioner want to see in this roadmap?
So I think there are two or three things that really really stuck out. The biggest the topic that was talked about the most by far, actually, but by far, was the improvements to the interface between academia and industry, especially startups. So that was the first thing that many people spoke about. The second thing and the third thing were probably about equal. The second thing would be support for open source and training in open source technology. And then the third thing would be funding for startups. Lots of people spoke about access to computational resources as well, which is under the same topic.
Cool. So on that first topic, the access and interface to academic resources. I guess resources by which I mean people and their knowledge. But yeah, basically, what were they wanting to see? Like, is it essentially the disconnect between the algorithms and methods and models that are being developed in academia versus what's actually needed in the real world? Is it essentially like bridging that gap or debugging help? What are people looking for?
Yeah, it's a really good question. So there are lots of different things. So one thing that many people spoke about was what you just said. There seems to be a disconnect between what academia is producing and what the industry really needs. So people were really speaking about, they were talking about the interface between academia and industry, but they weren't really talking about knowledge. And lots of people spoke about knowledge sharing, but not necessarily just in one direction. We assumed that they'd be talking about sharing knowledge from universities to industry, but actually just as many people were talking about sharing knowledge in the opposite direction. And that's partly because they wanted to make sure that people working in academia understand what the problems are that industry care about. So lots of ideas around feeding back information about use cases back to academia in order that they were focused on the right problems. But also skills. That's another thing that came out, that the impression that people have is that academics are not necessarily familiar with the modern software engineering skill set. But also, so that's those two things. One is feeding back use cases from industry. The second is feeding back skills from industry back into academia. But then the third thing is definitely probably what we all expect, which is that industry really expects to be gaining access to cutting edge ideas, techniques, methods from academia. And that, I would summarize by saying that people think that is broken. It doesn't seem to be working very well. And it wasn't covered at all in the roadmap. And it's not necessarily covered really at all well in the national strategy now that's published either, which is really odd. And to go back to the idea that a strategy needs to be more than a list of just a list of goals or objectives. And Richard Rommelt's work, he says that the first thing you should do is figure out what the obstacles are, and then figure out how you resolve those obstacles. That's what the strategy should be. The strategy should be a coherent plan for surmounting those obstacles. So the first thing is to figure out what the obstacles are. It feels from our survey that a major obstacle that people feel in the industry is that this interface is not working very well. And I think one of our major criticisms of both the roadmap and the strategy is that they're not really doing anything, or doesn't seem to be any ideas there for fixing this, which is a real shame because the UK has got great research in universities, great machine learning researchers. It has some really great engineers working in startups, and there's great potential in the UK for an AI industry to develop. It hasn't really developed yet, and I think there are some doubts about whether it's going to develop. And unless we can get that interface right, I think that we're going to struggle.
Yeah, just correct me if I'm wrong, was like the exact quote something like, if you have not enumerated the hurdles, you do not have a strategy. Something like that, where effectively...
I don't know the exact, I can't remember the exact quote, but it's not that's a paraphrase, but yeah, it's a good paraphrase.
Yeah, it was just basically like, you have to know those hurdles. And like, I have to say, thematically, this does connect very much with essentially the paper that you wrote in the feedback, because effectively what I saw in the problems that you're talking about was like essentially like problem solution. So like the problem oriented, and well, effectively like you're trying to debug the system. Um,
I
and
guess you
so
take an engineering type of approach.
yeah, and actually on engineering, so you mentioned several important things. One, effectively like in academic training, where a lot of people in the machine learning, data science, AI, these quantitative fields, they will become good at a certain aspect of quantitative research. But for example, the software engineering skills that are increasingly needed. And it's not like you need to be an expert software engineer, but you need to know how to function within around software engineers and some of these best practices and principles. That's a key step that is missed a lot of the time. So, for example, I was interviewing Charlotte Dean a little while ago, and her episode's probably going to come out a week or two before this one does. But she's talking about how she brought on software engineers into her group to essentially handle a lot of that stuff, and that's really good to essentially make sure that that interface and that output does work well with essentially the software engineering principles of people in industry who might be using it. And just as a quick side note, for my own work, like coming out of DPhil, and I had like the data analysis skills far more than I would need for essentially the job, or effectively your skills at data analysis typically will exceed the challenges of the actual applied topic. But you might lack the engineering skills to actually make the most of all that. And so effectively one of my biggest like hitting wall instances was like, okay, what are the data engineering skills that I need just to get things working? What are sort of the software and the code reviews and types of those things, so I can function with another team? Because effectively, academia is good for being a hermit in many ways, but when you need to interface with a lot of other people, that is a challenge. And I don't want to paint all academic groups like that, because one, that's a broad brush and be inaccurate, and two, some academic groups really address that and have big success, but it seems like it's not the case. When you're hiring people, for example, straight out of school, because I think this might address the question very directly, do you find that like a lack of these engineering skills or sort of the peripheral skills to just raw data analysis, are those lacking in people? Is that something they need to pick up when they join a company?
So we always have a programming task now as part of our interview process. We didn't used to, but we found that we had to do that. And this is because there are many people they may be really good at machine learning, may be really good at research, but they just cannot program, or they just don't program very well. They just can't structure code in a good way, and it doesn't seem to come naturally to them. So we have a test now, which was we always have the programming test where we ask someone to write some code for us. And that's I think that's just an essential thing that we need to do. So we don't have problems with hiring people who can't code well now. That just doesn't happen. I would say that I've worked with people coming from a computer science background. I mean, most people in data science, at least originally, before there were data science programs for MSc programs, they either came from a machine learning background or they came from a statistics or science background, empirical science background. And what we found with people who came from a computer science background is that they often didn't have, obviously they could program, so that those skills weren't at issue, but it was basic. I would call them basic scientific skills, the scientific method, formulating a hypothesis and testing the hypothesis, reporting results, reporting data. These are the skills that I found are often quite lacking in computer scientists. I think there is just a different tradition and culture there, that all of these things would be, how do you use a scatter plot to represent data, which comes naturally to obviously to all statisticians and to very many, or no, I will say all empirical scientists. Any physicist or biologist would be taught these things in their first year. And yet I've worked with people with PhDs in machine learning who didn't know how to make a scatter plot, a good scatter plot, and didn't know how to represent data, and didn't really know how to test a hypothesis. So I think those are the skills that I would really like to see being taught a bit more.
Yeah, on that note, because like people, when you talk about essentially scientific reasoning, the critical reasoning of scientific processes, for example, I think that it's non-trivial. This is a skill that's built with experience, and essentially a good intuition for how things go wrong in scientific processes. And my sort of, I don't know, you can just call it a quick napkin approximation or sort of like off the wall theory on this is that basically I think that when programs overemphasize a lot of the deductive aspects of their field, so for example, in computer science, you have a lot of mathematics, which is a deductive form of reasoning, and you can become extremely good at deductive forms of reasoning without actually figuring out the inductive aspects of reasoning, which are key to science. So effectively, I think statistics and all these academic fields have a place where essentially someone could be totally focused on the deductive or mathematical aspects alone of their field and make a lot of progress and never get around to actually trying to reason about real world properties and real world things. Because like the inductive aspect, well, it's just for those who have only listened to like one episode of mine or zero. The deductive means that if your assumptions are true, you can work through and you come out to a correct conclusion. Whereas inductively, it's this observational aspect, and it's reliant on those observations being generated by the same process and that process not changing, and how you can be fooled by it. So one way, this inductive and the scientific aspect, you can always be wrong, you can always be fooled, and this is something that even bothered David Hume. But anyway, getting back to this academic versus practitioner issue. I think that part of this, I think that at least some kernel of it has to do with the fact that academia allows you to essentially focus on, it can allow you to specialize in this one aspect. It might even prize that one aspect, like consider a statistics course where you can't get through without mathematical statistics. But you could probably get through without, statistical, like scientific reasoning. Anyway, so I think that's really interesting that you're bringing that bit up. If you don't mind me asking one more time, just to reiterate this, because this is super interesting what you said. When you say that someone can do machine learning, but they can't code, can you go through what that means? So can't code well, because effectively, like you can't implement a machine learning model without coding. Are you talking about like structure, the logic behind it?
Yeah,
Parsimonious, what is it?
You're right. You can't implement a machine learning model without coding, but you can definitely implement a machine learning model without coding well.
Yes, very good. Yeah.
I think, I think this kind of, in the early days of data science, let's say, when did data science start? Kind of about 10, 12 years ago. In the early days, there was this idea that you had data scientists who would just be the scientist and would be doing research, and they would be producing some prototype models that engineers would then turn into something that could actually be used in a product or service. That idea just didn't work very well at all. And people have, I think, unanimously agreed that was a bad idea. And so now most people that I know, the people developing the models are also developing the production code. I think the reason why, by the way, that it didn't work very well is that very often something was lost when the prototype model was given to the engineers. And it just, when it was turned into a production system, maybe it was really fast and it was really performant, but it didn't actually do the same thing that it did when in the hands of the original researcher. It didn't have the same performance, or there's some edge cases that were missed, or something like that. So now I think people have got the idea that so actually the person making the production code, or at least involved in making the production code, has to be the original researcher, which means that we need to now be making production code. Now, writing production code with everything that goes along with that, there's a very well-established toolbox of techniques like exception handling, use of assertions, the way that we structure code, the way that we name, the way that we name functions or variables is really important. That's something that people writing production code really care about. What's the name of your function going to be? How do we make sure there's a proper separation of concerns, and how do we make sure that the functions are coherent and make logical sense together? Loads of those things, I think, can be missing from research-based code. And I used to be a researcher, and my code, wasn't very good at. I mean, it was fine for those purposes of writing quick scripts to test ideas. And really, if you're testing scripts, there is an argument. If you're writing code just for testing ideas, then there's an argument that you don't really need to write production quality code. And I think that's probably right. But I think there's a middle ground, because I think, well, at least I used to think, you write a piece of code, a script to test some idea. It's just a one-off. You're never going to use it again. That's a totally different thing to writing production code that's going to be used every day. However, it's not really true, I think. I think it's a bit of a myth, because in reality, you are going to be running that piece of code very many times. You're going to be making modifications, and you're going to need to compare one version of an algorithm with a slight tweak of that same algorithm. And in the end, you are writing something that's going to be used, at least in your research process, as almost like a production system, because you need it to be stable, and you need it to be reproducible. So I think that even if you're only writing research code, you do really need to be writing something which is approaching production level quality. But definitely the way that we work is that all scientists will be writing the production code that's actually used in the product as well.
Yeah, I have two questions about this. One, do you think there's a way that we could essentially, production code can make you more productive even for academic research, although you essentially lose out on that ability to quickly write something up in MATLAB, test an idea. Do you think one of the ways to incentivize this is essentially to essentially try to create whenever you want a system to change, you have to figure out some way to incentivize it in some way. And so effectively, do you think that convincing academics that production code will actually make them more academically productive is useful? And is that sufficient to make them want to overcome those barriers?
Well, I think having to publish the code itself is probably a good way of incentivizing people as well. Mm-hmm. If people are forced to publish the code in order to publish a paper, then I think that's the ultimate encouragement. But I do think that you're right that if people working in research were delivering code of production quality, that their research would just go faster. But that's the kind of getting people to eat their vitamins type of approach, which eat their vegetables and take their vitamin pills. I'm not really sure whether that's going to be really that effective, because it's always easier to just do something quick and dirty. Mm-hmm.
Actually, even on that note, the eating your vitamins versus I don't know, I just swallow my vitamin and try not to think about it. But maybe it is that thing, we're telling people to chew their vitamins as opposed to no, you're meant to take this with water. But yeah, what do you think? So you've described, everyone wants a data scientist or machine learning person with the data analysis skills. And now essentially we've also described that, and I think very reasonably, that these people need to also have, production code writing ability. Where is the place do you think is to learn that? Is it entirely in school before they come out? Or is it we need to get them 50% of the way there so then they can learn the rest in industry? Where should the production code knowledge begin?
That's a good question. Yeah, I think, I think things there are skills you need to know these days. You need to know how to use Git, right? But I wouldn't think that learning how to use Git would be something that you should cover in an academic course necessarily. I mean, it can be, and I think it's fine if it is. But I like to think of academic courses as giving you knowledge which is a bit more is going to last a bit longer than the latest tools and techniques that are used in industry. I think you really go to university to learn some fundamental skills. So I would like to see more of the fundamental skills, like how do you structure code. If you learn that, that's never going to go away. That's never going to get old, and there's not going to be some new trend that's going to stop that being effective. That's information and knowledge that's going to last with you throughout your career. So those kind of more fundamental aspects, I think really should be taught at university.
Cool. And then obviously the data analysis side, just because that's a flip side of the coin, everyone wants people to be good at data analysis. And I really appreciate your insights on this, because this is very interesting. I've typically seen it where effectively your data analysis skills are always going to be highest when you're at university, because essentially typically a lot of the applied problems, once you encounter an applied problem, all these real world problems, things come up your coding and the deployment of it and the data wrangling and things like that. So effectively, all those things get in the way of you applying the most fancy, newest techniques. But do you think that effectively sort of that data analysis and the critical scientific thinking, because I view data analysis as a scientific task as long as it's being applied to a scientific domain. And there are domains that generate data that aren't scientific. But basically, should all that and data analysis skill, is that some of the things that you think should be being taught in the universities first?
Absolutely.
Okay.
Absolutely. These are the fundamental skills that I think you really should be learning this in the university. I think it's quite difficult to learn these skills in industry, actually. Also, I don't think we're really just talking about skills. I think we're talking about a culture. Scientific culture is about questioning the data and being skeptical. And I just don't think this is something you can learn from a textbook or even necessarily from, a YouTube tutorial. It's something that it needs to be imparted to you by someone who represents that culture. I think there is a really strong cultural aspect to this that I think people miss sometimes.
Yeah, I mean, it's not something that critical read. There's been some debates about whether or not, for example, critical thinking can be taught, and I don't believe that critical thinking can be taught like in a course type thing where essentially you lecture people on how to critical think, because even the fact is, if you take those and apply it, you're not critical thinking, you're just mimicking. And I think that there has to be, I don't know, there's some aspect where it has to be like that dialectic with an experienced skeptical scientific thinker, and then you also have to be basically out on your own doing it. You have to be able to survive in the wilderness of science, and it's learning those survival skills and picking yourself up again when you make mistakes that teaches those skill set. But I definitely get what you're saying. I mean, like, at Oxford, the feeling of, the scientific community, like that critical thinking, skeptical community where essentially thoughts can be entertained. You just need to bring up the data and the reasoning to support it. And I feel as if there's a big cultural difference there where you can really feel it, like in the lecture halls and things like that, and then in these conversations. And when you move into industry, obviously we've become so focused on getting stuff done that those conversations still happen, but not with the frequency and not with like the intensity that they happen in these academic environments.
Yeah, I think that's right. Normally when I see a result now, immediately I think the result is false.
Yes.
I think that was probably a bug, or probably the data hasn't been collected properly, or maybe we didn't set the question quite right. And there's chances, it's much more likely to have something wrong with it than actually to be a real result. And that's true. I mean, I've just made so many mistakes in my life, and I've believed the data when I shouldn't have so many times, and I've been hurt by that so many times that my instinct is to distrust everything, which is why I really love stuff like hand labeling my own data before, obviously you can't do that at a large scale, but at the beginning, I do that because I feel like that's the way for you to really understand the problem and for you to understand what kind of problems can crop up while you're labeling the data. And then half the time you realize actually the labeling task doesn't actually make any sense itself. And you need to change the way that you're asking the annotators to annotate data, for example. So I think that you really need to be obsessed with the data collection and data analysis questions right from the beginning.
Yeah, I think that I like your idea. I too take the approach that pretty much like anything that I read in a publication, I'm extremely skeptical of. And especially, more importantly, any good news that I have from my own results, I'm immediately like, there's no way this is right. It's like, there's something in here. There's some special like demon or gremlin in the machine.
Data leakage.
Yeah. So it's got to be in there. I just haven't found it yet. Like if you have a good result, it just means that you haven't found the bug yet. And as far as like building these systems, like when you say it's more likely that there's something wrong in there than not, I think this comes back to that issue with like the deductive things, because effectively a lot of these data science and machine learning systems are they're highly formal because they're done in a piece of computer code, and you only need one wrong, essentially, deduction or one wrong path to send things off in a way that is essentially unpredictable. There's like a chaos in the system.
Hmm.
And I think that's why that skepticism is so well warranted. But yeah, no, I'm glad that other people think similarly, because otherwise I wonder if I'm just like too pessimistic about things. But yeah. Hey everyone, we're in the final stretch of our episode. And before you go, I'd really appreciate if you could give me feedback on three things. First, what was your favorite question of the episode? What did I do right? Secondly, what question did you wish that I asked but didn't? And third, what questions were brought up by this conversation that you'd like answered in the future? That's it. Enjoy the rest of the episode. Um, so I think we've talked about some of the issues about practitioners. Is there anything that I've missed again so far? Because you know too much, and I need to make sure that like I can't really guess what you know that we need to know. Is there anything else in this sort of practitioner field? We talked about the hurdles from going from academia into practice that should sort of be discussed.
No, I think we've covered a lot there, I think. There are definitely other things which came up in the survey,
Hmm.
which were maybe not quite on that point, but other things like I said, that the other things that people really cared about were things like open source.
Yeah. If you don't mind, before, because I definitely want to hit on these other points, but since we're on the topic of startups prior to this, is there anything aside from the practitioner who's essentially an employee of a startup, but as the CEO of a company, is there something that you would have wanted to see in this that would have been more useful that isn't covered by the other points?
Um, well, I mean, one thing that actually is covered, you know, that I care about is the immigration policies. So there actually is now in the new national AI strategy some liberalization of the visa regime for people with specific skill sets. So that is welcome news, and that is something that CEOs generally care about, things like being able to hire people. So, and we care about that. So being able to bring people in from other countries is really important to us.
Yeah.
Um,
Is that like the tier four? Are you talking about the tier four visa? Is it currently
I
under
think
tier
it's,
four?
it's I think it's tier four.
Okay.
There's a change to make it slightly easier to get the tier four visa, I think. But it's very welcome. That but really something that people struggle with, I think, is access to compute power. When I talk to other people and other founders of AI startups, it's just access to compute power comes pretty high up the list, and also academics. For really, really, these days, if you really want to build a big model, then it's very difficult to do that outside one of the large technology companies.
Yeah. If you don't mind me just rewinding just like 30 seconds back, just to maybe explain this better. For example, the tier four, like for example, universities themselves basically have no problem hiring people from other countries and bringing them in,
Mm,
because essentially they have the bureaucratic infrastructure by which they can essentially go talk to the government, get all those licensing things set up. Whereas for these smaller companies, effectively, unless it's absolutely fundamental to like their existence. There's a large burden for these small companies saying like, no, not only do you have to run your company, but effectively you have to figure out how to manage the bureaucracy to essentially get licensed to potentially hire someone from abroad.
yeah,
And that
absolutely.
was my understanding of it. Even like just as a crazy example, and maybe this is a bit too much of an insular reference, but like I think I checked like Angrid Thai, near the Oxford bus station, for example, has like a tier four license, but the technology companies along that were building along Cali and along Main Street, they couldn't afford one because they were too small. And so
Yeah,
effectively, it's like unless you're hell bent on structuring your company around having this one sort of regulatory hurdle, you don't get that talent. Whereas like a large company, they have nothing better to do than essentially assign their lawyers and their managers and things to overcoming those hurdles. So effectively, it creates a system, at least as far as I can perceive, where like startups essentially are at a distinct disadvantage compared to all these other large institutions because they have to jump over these hurdles that it's just one too many.
Exactly. It's gonna you need to do a lot of paperwork, and you need to hire a lawyer to do it. It used to be quite expensive to do it, and it just takes time. So normally, if you want to hire someone quickly, you just don't have time to you don't have the 3 months that it will take to go through, jump through all of those hurdles. So I think that this is going to change. So I think this in the strategy, if I understand it correctly, the new strategy has a couple of paragraphs in there which say that now that people are going to be able to come into the country with exceptional talent or skills, and they are not going to be tied to a specific job, which means that someone can come into the country and they work in one place, they can leave that place, and then I can hire them without having to, be a sponsor, be registered as a sponsor of a visa, etc., and go through all of the paperwork that you mentioned.
Cool. Yeah, I think that's important to point out, just because basically when people talk about what amounts to a hurdle, that definition changes by what institution or what organization you're within. And so effectively, you can see why in academic institutions or giant companies, that wouldn't even seem like a hurdle to them, that won't register for them because it's not handled. Where someone who's essentially, in the chaos of a startup, it becomes prohibitive. So talking about the other prohibitive thing, computing power. So how does this work out, where effectively we have big companies that have access to the type of computing power? Some academic institutions either have their own high performance computing clusters, but what would sort of those startups need to see that they can't get on AWS and things like that, or Google?
Yeah, I mean, I definitely don't have an answer here. I don't really know what the right answer is. Some people suggest that the government should directly fund credits on cloud computing services like Google and AWS. So you're right that any startup can buy computing time on the cloud, but it's really expensive, especially if you're using GPUs. So for small startups, it's just too expensive. So some people have suggested that we fund startups with cloud, credits. I'm not sure that's a great idea, actually, because you're basically just transferring money from the UK taxpayer to Google or Amazon. I'm not sure that that's really what we should be about if we're trying to build up an AI industry. And you're also, I think you're teaching people not to not be capable of running your own cluster or your own compute infrastructure yourself, and then we lose those skills in our labor force. I don't think that's great either. I've used the phrase learned helplessness about this before, that we're just going to teach people to be dependent on Google and Amazon. We care about the UK. This is a UK strategy. So I'm not sure that that's the right approach. I'm not sure what the right approach is. Some other things have been tried. So there is a thing called I think it's called the Machine Intelligence Garage, run by the Digital Catapult, which gives startups access for 6 weeks to a small cluster, I think, or a machine with a few GPUs. I've never used that service. So we've never used that service because 6 weeks. I mean, 6 weeks is just about enough time to discover a major bug in your code, I think, and realize that you need to run everything
Run
again.
it over again, yeah.
Yeah. 6 weeks is just not long enough for my purposes. So we've never used that service. Maybe it's useful to some people. I'm not really sure. But so I don't have an answer there. I don't have a good answer to what the government should do. But I do think that it's a problem. I do think that at the moment, at least, it does seem like very, very large amounts of compute power are the way to build the models which have really really, really good performance. So something that I think it's holding us back a bit in the UK. But I don't have a good answer for what the government should do about that.
Yeah. And I'm not sure how much of one. I appreciate the sort of like answer when something's up in the air. I love it when people just come on, just like free think about what the thing might be. But one thing that, like, for example, in the US with US tech salaries, and you look at the cost of computing versus the cost of essentially someone in the actual person in the tech sector, and effectively computing is frankly pretty inexpensive compared to the cost of like hiring a full blown person. Do Do you think that effectively in countries where effectively like salaries are lower, so you just look around the world, that more and more the computing can essentially become more expensive than the actual tech worker? Is that a thing that's interplayed, or is it just more just the upfront cost of computing is?
Mm. Yeah, it's an interesting point. This could be something to do with that. And also, I mean, the funding environment is different in the UK compared to the US.
Yeah,
So, you know, that has something to do with this, I think.
yeah.
But also, it's worth saying that it's not just startups. So, the very many academics also saying they don't really have access to the compute power that they need.
And if you don't mind me asking, is it access to compute power, or is it access to compute power plus the computer skill set training? So effectively learning how to use these things effectively. For example, you have someone who's working on desktop MATLAB. I am to describe myself during my DPhil. Like that doesn't naturally train you to be using like Ubuntu to spin up some cloud computing resources. So is there the skill gap plus access that is part of the problem?
Yeah, I mean, I'm not so much worried about that. I think people can learn how to use these tools and learn how to use cloud compute. I don't think that's going to be a major problem. I think that something that's going to hold us back as a country is if we just don't have the skills to build very, very large, let's say large language models. If we just don't have the capability, we just don't have the skills for building, large compute clusters with thousands of GPUs in them, billions of models with billions of parameters. Those are skills that we don't currently have in the UK, and I think that if we don't develop those skills, then there will be a problem with us catching up or staying in the race.
Cool. Now on to the other, just so we don't lose too much time and we get to cover the rest of what your document talked about. What were the other concerns beyond that were important to address?
So quite a lot of things. Some things people were directly responding to ideas in the AI roadmap. So one thing that people really didn't seem to like was the idea of the moonshots. People were really worried about moonshots becoming very, very expensive projects, which were kind of vanity projects and didn't really go anywhere. And it was nice to see actually that the moonshots were no longer in the strategy itself. The strategy document itself didn't contain anything about moonshots. So yeah, lots of people were talking about that. The second biggest thing that people cared about after the interface between academia and industry was open source. So support for open source projects and also training for open source technology. That wasn't covered at all in the roadmap, and it was also not covered at all in the strategy. And I think this is a big black hole in the strategy. I think this is the result of not really speaking to any practitioners at all when formulating the strategy. I think it's a missed opportunity. I think that open source has a lot to offer. Lot to offer what's our goal here? The goal of the strategy is to build the UK AI industry. And I think if open source needs to play a part in that, because open source plays a huge part in AI, and it wasn't covered at all.
For things like open source, for example, I believe, there's like Columbia has had some pretty good success creating certain Python libraries, via open source and things like that. What do you think, is it simply a matter of making sure that academic institutions are openly publishing? So they're publishing their code along with their publications, that they have these open Gits that people can look to, and that those Gits are of sufficient quality that people can use? Is there anything, those seem sort of like the facile, the sort of first order approximations of what to do. What more specifically would people be needing in terms of open source?
So actually people were much more interested in supporting existing open source projects.
Ah, okay.
So the idea is that we would, as a state, we would hire individuals to work on open source projects in the UK, or there would be some funding available in order to do that. And the idea, many people put this forward. I mean, or at least agreed with the idea that this is what Columbia did. Columbia did actually. They hired some core developers for the scikit-learn projects. So scikit-learn is the machine learning, that kind of one of the main machine learning libraries for Python in the Python ecosystem. They hired some core developers at Columbia University, and these guys, they acted as a kind of nucleus for the machine learning community. They held workshops, they held tutorials, they did meetups, social networking, and but they were able to do a lot of knowledge sharing with the local data science community. They're working on cutting edge techniques. They're able to share that knowledge. They're able to teach people how to contribute to open source projects, and really, that community building and that cultural aspect was really important, and it was really successful.
Cool. And is that all that we should have covered for the open source bit? Because obviously that is what you just mentioned, essentially directly supporting the open source development is something that we've all benefited from. But as you could just tell from my question, it didn't immediately come to my mind. Was there anything else as far as open source that we should be sort of concerned about? Are there facets of open source? For example, like the open sourcing of education or the open access to learning materials. Is there anything like that?
Yeah, I mean that's really it's really important that code is available with publications in order that people can reproduce the results. This aspect of open sourcing is really important. It wasn't actually covered in our survey. Not many people really spoke about that. But I think if you care about reproducibility in research, then it's very important that people do open source their code.
What about
Sorry, I was just going to say that I'm not sure whether they necessarily need to open source the code, but they need to make the code available, which is not quite the same thing.
Yeah. What about open source data sets? Were there anything where effectively that there are certain data sets that people would like access to? I know in the UK, you have the UK Biobank as an example, and that there's a lot of well-known machine learning sort of reference data sets. Were people wanting access to certain aspects of data that they couldn't have previously?
Yeah, so a few people spoke about this. There was nothing really specific. People weren't really talking about specific data sets, but they were saying, generally speaking, they would like to have more access to data, that government should try to make more data available. But to be honest, I don't think, I think the thoughts were quite vague there, that there needs to be more access to data. So I don't know whether if you ask 100 people, 100 data scientists what they care about, I think probably most of them are going to say they want more data all the time. But I don't think there's anything really specific in there about open data.
Cool. And as far as the moonshot work goes, because I know we sort of talked about that for a second, were there any moonshots? What were some of the examples of these moonshots?
I think the main example was the digital twin idea.
Okay.
That maybe you can explain what this is.
I was actually going to say, like, what were some interesting examples of the moonshots? But if digital twins is what they got, it's like, okay, cool. Next question. But yeah, so I guess for that, I can't help but really be attracted to the idea of are you going to be funding vanity projects, for example? Sorry, were the moonshots taken out of the strategy?
There was nothing about moonshots in the strategy.
Okay.
Which I think is a good thing. Yeah.
Yeah. Okay, cool. In that case, maybe it's not worth really rummaging over too much. But, there are so many elements, especially there's so many things that can be open to vanity projects. And you can even consider a lot of academic research where effectively if it doesn't have a particularly compelling real world case, but it is something that's really catchy, or effectively, you do a publication that looks good it might look good. It's like, oh, we can do like certain types of prediction. But then when you look at the data that was used, it's like, well, I don't really see how you could be drawing these inferences from the data that you have. And then you're saying, well, okay, then essentially the only thing you've done with the paper is created a headline, but it's not really, it's something that maybe a newspaper might talk about, but it's not something that an actual scientist would take and believe. And I guess when I think of vanity projects, I think that there's like a micro level of vanity projects where effectively you can do things that create a lot of headlines in your research, without actually pushing the field forward. And so having
Well,
that writ large, go on, sorry.
Well, I was just going to say that in this case, probably we're talking about vanity projects for policymakers,
Yeah.
or politicians. Politicians love to have a flagship moonshot project that they can announce, or a flagship institute that they can open, but I don't think many politicians are really excited about supporting an open source project. Whereas there's this big disparity between what people in the practitioner community really care about and what policymakers really want to push forwards. That's that's the cynical view. And like I said, the strategy didn't contain anything about moonshots, so I think that was a really good outcome.
On the issue of people creating large institutions, because I just want to bring this up. So obviously we have the Alan Turing Institute. What was because one of the most interesting things that I thought, because I obviously respect the Alan Turing Institute greatly. I think they do a lot of cool work. It's very exciting. But at the same time, some of the feedback was saying that that they didn't think that the Alan Turing Institute was focusing on the most important things. Am I paraphrasing that correctly, or did I get that entirely wrong?
Yeah, I think that's right. I mean, people use the term ivory tower.
Yeah.
But there was also just a lot of indifference, and hardly anyone actually mentioned the Alan Turing Institute. So, it's supposed to be the flagship data science and AI institute in the UK, and yet practitioners, it doesn't seem to have any impact on practitioners' lives or work, which is interesting, I think. Should we care about that? I think we probably should care about that.
Well, caring about it seems like it being the flagship seems like it would be conditional on people caring about it, presumably, right? Because one follows the flagship, or at least takes their flags from the flagship, right?
Yeah.
Like if the flagship isn't waving the flags, it's not the flagship.
Yeah.
So, I'm thinking about Horatio Nelson now, trying to build that analogy more. But yeah, you get the idea. It's like presumably its status should be conditional on how it affects people, and perhaps is it having a high effect on people with an academic focus and not having an effect on the practitioners? Is that the divide?
I think so. I guess we need to get down to what are the KPIs that the Alan Turing Institute is being measured on. What's its goal? How do we know whether it's been successful so far? I don't think it's quite clear what those KPIs are, and I don't think it's quite clear. Everyone says it's very successful, but by what metrics is it successful? I'm sure lots of papers have been published, but again, this comes back to this disconnect between industry and academia in the UK. I think it's a real thing. It came out in the surveys, but something that we've seen ourselves in conversations with data scientists. There is this disconnect where we're talking about being world leading and leading the conversation. We have the flagship institute, which is very successful, and yet at the same time, the flagship institute doesn't seem to be affecting the lives or careers of any of the data scientists who are actually out there in industry building products, building services based on machine learning or statistics.
Maybe you have a good idea about this, maybe you don't. Do you think that the article that you wrote had an effect between the roadmap and the strategy, or effectively what you did carried some weight, or might have been heard by somebody, or changed?
I think it's definitely been heard by people. We've had a few quite positive meetings with the AI Council and the Office for AI, who are running the strategy. This is the UK government department who are running the strategy, or producing the strategy, and it was definitely read and people took notice. I don't think it had any impact at all on the strategy. That really, for reasons of timing, the strategy came out very shortly after we published our piece, and a few people on the AI Council have publicly tweeted that they did drop the ball a little bit when it came to open source, and that is something that they should have really been looking at, which is great. So we've had some really interesting conversations since then, and we're hoping to work together in the future to influence what happens next. We feel like we've got pretty good connections with the practitioner community, so we can bring those two worlds together and get this conversation really started. It's a shame that the conversation hasn't really happened yet. It's just starting, but I think it's good and it's really positive. And to be honest, the Office for AI Council, they've been really, really receptive. So it's been really positive.
Yeah, and it also just seems like it seems like you are part of a community with that has some very exceptional people in it. Like I have some bias about this, just given people who I look at and what I read from them, things like that. But when I see people like you and Jim Weatherall, Pierce Dobbs, maybe it's great having those people all together working and thinking about these issues. Because I can't help but get the general impression that you guys, I don't know, maybe have conversations sometimes. That it seems like a group of people who can have a good perspective and can actually get things done. Again, getting back to that community issue, that sort of vibrant community do you think that effectively there is this vibrant community that is pushing things forward, even if it isn't, for example, represented in this roadmap?
Well, you mean you mean
like
around the Royal Statistical Society and the work that we're doing?
Yeah, for example.
Yeah, I mean we used to run loads of events in person, which are really fun, and we got to meet lots of really, really interesting people. And we were building a kind of small community around that, but then pandemic happened and that started. And we've been doing some online events. And Piers, you mentioned Piers Dobbs, who's writing the newsletter every month as well for the section, which is really great. I think everyone should definitely check out. I mean, it's fantastic.
It is a great newsletter. Actually, one thing that I'd like to do is start doing a running commentary whenever he publishes it. I'll actually publish an episode where I go through and I just go through and read and highlight some of the key things. Because basically it's like once a month, if you want to get an immense update document, I'd actually put it on the level of like the batch AI updates, as in things that I'd like to read just to get a high level overview. The critical thinking, it's not some joke newsletter written by someone trying to get something out. It's like he sat down and provided editorial value.
That was great.
To a large thing, yeah. So I'll pop a link in. Yeah.
Thank you. Yeah, I don't know how he does it, to be honest. It's absolutely amazing. But yeah. So we're using these tools to connect to people, but we would love to go back to in-person events, of course.
Cool. In our last few minutes, there's a lot to cover. You know a lot. What is something that I forgot to ask, or a topic that I forgot to cover?
That's a good question. I think maybe one thing worth mentioning is that we now, it's 2022 now. As a committee, we're trying to figure out what our focus should be for this year. We think that it will be this idea about interface between industry and academia, because it was such a big deal in the survey results coming back. We think we need to try and do something to help. We're not sure what we're going to do, but we're coming up with a program of events right now, which will hopefully help to bring people together and build that community that we think is a little bit lacking at the moment. So I don't have anything concrete to say about that, but that's something definitely to look out for. I think it's going to be quite exciting.
Cool. And on the topic of moonshots, what do you think it would be a very cool accomplishment or achievement in your lifetime for AI? Just would that be a moonshot, or do you think it's not a moonshot, it's something that's going to happen? What do you think would be a very cool AI achievement in your lifetime? An important one.
Well, it'd be nice if the machine learning models learned to generalize to different data sets. That would be really awesome. Mm-hmm. I think when a lot of the time when you probe into beneath the surface of some machine learning results, it's just obvious that when the model, which performs really well and performs better than humans on some task, when you give it some very, very slightly different data set, everything just falls apart, doesn't work anymore. This is a real problem, and it's a severe problem, and it's seen across NLP, computer vision, everywhere. It's a fundamental problem, I think, and it needs to be solved. It seems like humans and even animals more generally have a much more fluid intelligence that doesn't have the same kind of brittleness, and that's the big problem to be solved, I think.
That is very cool. And our final question, which I ask everyone, is what is one sort of topic or question that you'd like the AI community to debate.
Okay, I'm really interested. Like, I really don't want to get away from questions about, AGI and human level of intelligence. I would really like to know whether AI currently has reached an insect level of intelligence.
That is really funny. That is a great answer. Has AI reached an insect's level of intelligence? And with that, Dr. Martin Goodson, CEO of Evolution AI, thanks so much for your time today. I really enjoyed this conversation.
Thanks, Glenn. Great to talk to you.
Hey guys, it's Glenn. Thanks for your time today. I hope you liked today's episode. If you did, please consider smashing that like button. It's the single, simplest, fastest way to make sure that YouTube shows this video to more people. If you really want to go crazy, consider subscribing or going to our website and joining the mail list. If you want to go totally crazy beyond that, forward this to a friend or colleague who you think might enjoy this too. We're a small channel and every bit helps. Our next episode will be coming out next week, so in the meantime, feel free to look around the channel and see other videos that might be of interest. As a quick disclaimer, the views expressed in the show do not represent anything other than the people saying those words, views, etc. like that. It doesn't mean anything about their employers or their employers' views or some thing about their employers or their neighbor's cat or anyone else not saying the words. And in fact, given that people tend to change their views when they're thoughtful enough, it might not even represent the views of the speaker by the time you're hearing the episode. So definitely come back and see if they've changed their views at a later date. They also don't represent the views of our sponsors. Thank you to our sponsors. You can check them out on our website.